This is Unit 5, Lesson 1, Part 1. We'll be learning about monomials and polynomials, just kind of an introduction to this chapter. So monomials, in our first little box here, definition is it is a number, a variable, or a product of numbers and variables. Basically, think of mono meaning one. It is one term. So some examples include things like 4, like just a number, just the one term, or like 7x, just a single term, or something like 3x squared. So these are products of numbers and variables. So the important thing is that there's no addition or subtraction or division. You know, it's just one term, one expression. So we can use exponent rules to simplify monomial expressions. You guys did these in Algebra 1, so here's just a recap of those exponent rules. The product rule is this: if you've got something raised to a power and then that same thing raised to another power, our exponent rule tells us that we add those exponents together. So your new exponent is m plus n. So an example would be if we have an x squared times an x to the 7th, the product rule tells us that we add the 2 and the 7 together and we would get x to the 9th. The next one, the power rule. If you have a base raised to a power and then that entire quantity is raised to a power, the power rule tells us that we multiply those two together, and our new exponent becomes m times n. So if we use those same numbers from the previous example, if we take x squared, take that entire quantity and raise it to the 7th power, that means you have x squared, x squared, x squared 7 times. So this rule says that we multiply the 2 times 7 and we get x to the 14th. Quotient rule, if you've got a to the m and you divide it by a to the n, the quotient rule tells us that we subtract those exponents, and our new exponent would be m minus n. So if we have x to the 7th divided by x to the 2nd, we would subtract 7 minus 2, and our new exponent would be x to the 5th. Negative exponent rule. If you have a negative exponent like this, like a raised to the negative m power, our negative exponent rule, we are supposed to flip it down to the denominator where it becomes positive. So 1 over a to the m. So let's say we had x to the negative 2nd. If you ever see that negative exponent, you are supposed to flip it so that it looks like this. And once you flip it, it becomes positive like I just did. And finally, the 0 exponent rule. If you have anything raised to the 0 power, it just comes out to be 1. All right, so if we had something, I'm going to keep using these same numbers. If we had 7x squared, but we take that whole thing and raise to the 0 power, doesn't matter what's on the inside, it's going to come out to be 1. All right, so let's use all of those exponent rules, just kind of recap, and all of this should just be a review from Algebra 1. Nothing on this page is too crazy. So we're going to do a handful of these examples. We'll start with number 2. So this one, you're still following the order of operations, which means that an exponent on the outside like this would come first. So when this is squared, I am distributing this square. I'm squaring this and squaring everything on the inside. So this whole expression gets multiplied by itself. So if negative 2 gets multiplied by itself, then that comes out to be 4. If a to the 3rd gets multiplied by itself, a to the 3rd times a to the 3rd would be a to the 6th. And then b gets multiplied by itself. So b times b would just be b squared. So that's the first expression after I square everything that was in parentheses there. And then I am multiplying it by 8ab to the 9th. So this is now multiplication, and we have properties that tell us that multiplication is associative, which means that I can regroup and kind of change the order in which I am multiplying. So I can multiply the 4 times 8, which gives me 32. I can multiply the a to the 6th times the a, which is technically a to the 1st. So if I have 6 copies here and 1 copy here, that would be a to the 7th. Remember, this rule tells me I just add them together. And then the b to the 2nd times b to the 9th. Again, this rule tells me I just add them together, and I get b to the 11th. So that is my final answer. As long as each exponent is only written once, you don't have parentheses, you don't have big outside exponents like this, that means that that is your final answer. All right, let's do number 3. Number 3, we can start with division of this one right here. So divide 54 by 3. 54 over 3 is 18. M to the 6th over m to the 2nd. This rule tells me that I subtract 6 minus 2. So I get m to the 4th. This one I can subtract again, n to the 4th. And this is technically an n to the 1st. So I subtract and I get n to the 3rd. minus, and as of right now, there's nothing to simplify with this guy right here. So I have this expression, I have subtraction. It's the only subtraction on this whole page. There's a note right here that says adding or subtracting monomials, you can combine like terms. So like terms means that every little bit has to be the same. So m to the fourth matches, n to the third matches. That means these two are like terms because their variable part is identical. Same variables, same exponents, so then I can just combine them. So 18 minus 10 leaves me with an 8. And then the variable part stays the same. Like if you were doing 18x minus 10x, the x would still be there. So don't let the fact that it's a more complicated variable trip you up. All right, we're going to do the rest of the evens down this page here. So number 4, 2k to the fourth times 10k to the negative seventh. So I'm going to do something like I did up here. So multiply these together. 2 times 10 is 20. K to the fourth times k to the negative seventh. This rule tells me I add them. So add the 4 and the negative 7, and I get a negative 3. Then this tells me I have to use this rule right here. I have a negative exponent, so I have to flip it. Notice you do not flip the 20, because the 20 is just a number. There's no negative exponent attached to that 20. So the 20 stays, but the k to the third flips down to the denominator, where we write it as positive, just like we did here. Number 6, something similar. You can see this negative 1 right here. So when you have a negative exponent, like this part gets flipped down to the denominator, but if I had something in the denominator, that would get flipped as well. So really what the negative first exponent means is you want to take the reciprocal. All right, so anytime you see this negative 1 as an exponent, it means you want to take the reciprocal of something. So we're going to flip this. We're going to flip the 7w to the third up to the numerator, and we're going to flip the 14w to the 12th down to the denominator. So that's what that means. So then we can simplify it just like we did with this one. So 7 over 14 means we can simplify that to 1 over 2. And then w to the third, w to the 12th, we can use this subtraction rule. And here's a little trick. Wherever you have more of them, that's where they're going to end up. Because really what's happening is we're canceling out 3 copies of w. But since I have more of them down here, that's where my leftovers are going to end up. So I can subtract 12 minus 3, which is 9, and that means those 9 copies are going to get left down here. Because that's where there were more of them to begin with, so that's where the leftovers are going to end up. One last one on this page, number 8. We'll start with these big exponents on the outside. So raise everything to the 4th power here. So that c got raised to the 4th power. And then this c squared would also get raised to the 4th power. So when you raise a power to a power, you multiply them. So you multiply 2 times 4, and you get 8 times, and then do the same thing here. Negative 3 gets raised to the 4th power. You don't multiply negative 3 times 4, you use an exponent. So negative 3 raised to the 4th power means negative 3 times negative 3 times negative 3 times negative 3. And when you multiply all that out, you get 81. And then c to the 4th, because this c gets raised to the 4th power as well. So I want you to look at all of these copies here. These ones, this is kind of like over 1, so that I can combine these. So I have c to the 4th times c to the 4th, which would be c to the 8th, because I add them together. And then in my denominator, I have a c to the 8th. So these are actually just canceling out, and it just leaves me with an 81. Okay, so that's my stuff on monomials. On the next page, I have a bunch of stuff. Oh, no, I'm sorry. I have one more example here. Number 9, give an example of 2 monomials that leaves this behind as a quotient. So there's a reason it says give an example, because it could be anything. So a quotient, you need a numerator and a denominator. So let's see, what would reduce down to negative 3? And keep in mind, this is just one example that I could come up with. So if we had negative 36 over 12, that would reduce down to negative 3. But it could be 9 over negative 3. It could be negative 12 over 4. It could be anything that would reduce down to a negative 3. N squared, we want to have 1 copy of n squared left in the numerator, and we want to have 1 copy of m left in the denominator. So let's put an m to the 4th here, which means I would have to have an m to the 5th here, because that would leave me with just 1 leftover copy in the denominator. And then I need to have 2 leftover copies of n in the numerator. So let's put 7 copies here, and then I'd have to have 5 copies here, so that when I subtract, I'm left with 2. So that is just one example, okay? This is not like the answer to this question. We could have come up with 30 different examples. All right, now polynomials. So a couple quick definitions here. Polynomial is the sum or difference of many monomials. So like those single terms, but then you add or subtract. And then a couple little things we're going to mention here. The highest exponent of the polynomial is called the degree. So we'll refer to and classify polynomials by their degree. So standard form. Just so you know, with standard form, we always write these polynomials, always write with exponents in descending order. That's how you know that it's in standard form. So you start with the largest exponent and then you work your way down, and that's how you know they're in standard form. So we're going to do a couple of these. If we start with 10, we start with the largest exponent, so that would be the 5. So we're going to write this guy first, and then you go down from there. So then we need the 4th, and we don't have a 4th, so the 3rd goes next. Then the 2nd would be this. And then the 1st would be this. And then the constant, which would be this. So we got all of our terms. They are written in descending order, which is how you know it's in standard form. Let's do number 12 as well. I wanted to include this one because it's got a combination of x's and y's. So what you do with this is you go in alphabetical order. So the x's are the ones that you're going to put in order. So let's look for the biggest x's. That's x to the 1st, 2nd, 3rd, and then no x's. So since we're ordering by the x's, we are going to write this one first. So that's an x to the 3rd. So now if we look for an x squared, that would be this one. And then just an x would be this one. And then no x's would be this one. And the constant is always the very last thing to go. Okay, so like this one, since A is alphabetically first, we would have ordered it by the A's. Like the A to the 3rd would have gone first. So whenever there's a combo, just go alphabetically, and that's the one you put in order, because you obviously can't put them both in the right order at the same time. All right, last thing we're going to do here is classify polynomials. We use their degree and we use the number of terms to classify polynomials. So over on the left, I'm going to give you guys a little how-to. So if there is no degree, we just consider that to be a constant. Okay, that's why I was referring to the 2 and the -1. Those are constants because they don't have any variable at all. If it's just a degree of 1, like just an x, just a y, we consider those to be linear. That's like y equals mx plus b. It's just an x raised to the 1st power, technically. If it's the 2nd power, like an x squared, that's a quadratic. If it's the 3rd power, like an x cubed, that is a cubic. 4th power, like an x to the 4th, is quartic. You guys probably recognize that quart. We use that with 4s a lot, like quarters or, quarts. And 5th is quintic. Quint is the abbreviation for 5. Like if you've ever heard of like quintuplets, that's like 5 babies, so quintic. Number of terms. If there is only one term, just like on the previous page, we consider that to be a monomial. Mono means 1. If there are 2 terms, we call that a binomial. Bi means 2. 3 terms would be a trinomial. Of course, tri means 3. And then for 4 or up, we don't get specific with them. We just consider these all to be polynomials. Because poly means many. So once we get to 4, we just say that there are many terms. So these are our categories. We're going to do a handful of these and classify. So starting with number 13. We are going to classify them as one of these and one of these. So its highest exponent is technically a 1. So we consider that to be linear. So we say that this is a linear, and then there are 2 terms. So 2 terms means it is a binomial. So this is a linear binomial. So that's how you classify these. You take basically 1 from each category. So let's do number 15 as well. No exponent, which means this is a constant. And there's just this 1 term. So 1 term means it is a monomial. So this is a constant monomial. Let's do number 17. Number 17, the highest degree is 2. That's the biggest exponent. If the degree is 2, then it is a quadratic. And there are 1, 2, 3 terms. 3 terms makes it a trinomial. So just knowing how to classify. So let's do one more where we kind of go backwards. Give an example of a cubic binomial. So we want the highest degree to be 3, and we want there to be 2 terms. So let's say 5x to the 3rd. That makes it cubic because it's got a degree of 3. And then a binomial means we just want it to have 2 terms. So let's say plus 6x. Okay, so 2 terms, that makes it a binomial. And the highest degree is a 3. That makes it a cubic binomial.